Dear students, let's see this question. Here, two resistance R1 is equal to X ohm and R2 is equal to 1 ohm. Two resistances R1 X ohm and R2 1 ohm are connected to a wire AB of uniform resistivity. Resistivity is given. Resistivity as shown in figure. The radius of wire varies linearly along its axis from 0.2 millimeter at A to 1 millimeter at B. See here, actually in this wire it is uniformly varying, uniform resistivity is given, and this radius is varying from where to where? From 0.2 at A to 1 millimeter at B. It is varying. And he is saying that a galvanometer G is connected to the center of the wire. Exactly at the center, galvanometer is connected with the wire 50 centimeters from each end along its axis, shows the zero deflection. It is showing zero deflection. That means the bridge is balanced. When A and B are connected to a battery, the value of X is. He is asking what is the value of X. We know it is similar to the Wheatstone bridge only, right? So in these cases, we know generally P by Q is equal to R by S. When bridge is said to be balanced, under balanced condition, we know P by Q is equal to R by S. So in a similar manner, we can apply P by Q is equal to R by S. So here, the resistance, how much we have to calculate? Actually here, it is not a uniform cross section, right? It is uniform resistivity. Resistivity is varying. So in this case, here how much resistance is offering, and here also how much resistance is offering, we have to calculate. So from here to here, the resistance, and from here to here, the resistance we have to calculate. If once you calculate it, then if you apply P by Q is equal to R by S, then you will get the answer. Let's see this question, and this question is in JEE Advanced 2022 question. 2022. Now see this question, how to solve. So for this type of wire, for this conductor, we know already. Actually, you can check my videos, in that it is there. When the wire is like this, having the radius A and here it is B, the resistance and length it will be L. The resistance offered this wire R is equal to rho L by pi AB. R is equal to rho L by pi AB for this type of wires, where rho is resistivity, L is length of the conductor, pi A and B are the radius at the starting point and ending point. So the same constant I am going to apply here. So I am going to divide this wire into two parts. So I am going to apply the same formula at this point and same formula at this point also. Then automatically we can convert. Let's see this question. R1 how much is given? X ohm is given. I am replacing R1 is equal to X ohm and R2 is equal to 1 ohm. So R2 is equal to 1 ohm. Now I have to calculate the resistance offered here, the resistance offered here. So I will write here the resistance, I will write it is R1 and the resistance I will write R2. Now I want to calculate R1 and R2. Just try to understand. I am elongating this one. Here this rod is like this and this is like this. This one is given. Correct? And galvanometer is exactly balanced at the center point. So at the center point, I am dividing like this. Just I am considering this center, the radius is R. Center radius is R. And this radius is given, how much it is? It is given that 0.2 millimeter at A to 1 millimeter at B. So here it is 0.2 millimeter and here it is 1 millimeter. So now I am going to apply the same formula with this conductor and with this conductor. Right? Because I told you it is R1 and it is R2. R1 and R2. So how we can write? R1 can be written as, try to understand. R1 can be written as rho L, length is exactly half is saying, because galvanometer is connected to 50 centimeters, so it will be half. So I will get 50. Again, we are going to calculate the ratio. So whether it is centimeters or meters, it will not be affected, but because in ratio it will be cancelled automatically. So we can write only 50 upon pi. A is the first one, starting point. How much it is? 0.2. 0.2 into B. What is B here? It is R. So I will write it is R. So you will write R can written as 50 rho by 0.2 pi into R. Now I am going to calculate similarly R value. Just try to understand R value I am going to calculate. R is equal to again rho L by pi AB formula. Rho L is this length is 50 centimeter. Again this 50 by pi. A is the radius at the starting point. For this radius, what is the starting point? Starting point is R. So I will write it is R. And B is the ending point, 1 millimeter. 1. So we write R2 is equal to 50 rho by pi into R. So now if you modify this circuit, modified circuit I will write modified circuit, we can write as it is x ohm and here it is 1 ohm. So you can write here x ohm and 1 ohm. And here one resistance is there, R1, and one resistance is there, R2. And again galvanometer bridge exactly balanced. So it is a balanced Weierstrass bridge. So in this condition we know P by Q is equal to R by S. So P by Q. So P by Q. So X by 1 is equal to R1 by R2. R1 by R2. We will write X by 1 is nothing but X, which is equal to R1 50 rho by 0.2 pi R. 0.2 pi R upon R2. R2 value again 50 rho by pi R. So now we can cancel easily. So here it is 50 rho get cancelled. Pi R will get cancelled, right? So you will get x is equal to 1 upon 0.2. X is equal to 1 upon 0.2. It can be written as see 1 by 0.2 already we know how to write. Simply you can write 1 by 0.2 means 10 by 2, which is equal to 5 ohm. So x is equal to 5 ohm. This will be the answer. See, it is also advanced question only, but small topics. Clear? We are thinking advanced questions are difficult, but advanced questions are not difficult. It is conceptual questions. We have to understand the concept. I hope you understand. Thank you.